Good day, guys. We are looking at another problem on analytical circle geometry. So we've got two circles here with a common center at M. So that's what we've written there, that M with coordinate negative 2, 1 is the common center. Then AM is the radius of the bigger circle. You see the larger circle, whose radius is AM. YBM is the radius of the smaller circle. So the first part requires us to determine the equation of the larger circle in the form x squared plus y squared plus hx plus gy plus k equal to 0. So whenever we make the equation of a circle, the advice is always to start with this format. This is the format that will make life easy for you. For maths level 4 students, this is formula number 4 on their formula sheet. So with this format, we know that A and B are the coordinate of the center, which obviously here it will be negative 2 and negative 1, which is the common center. Then R is the radius. So it means that here we are only going to target the calculation of the radius for the larger circle. And we are told that the radius of the larger circle is AM, the distance from A to M. We all know the coordinate of A and the coordinate of M. So the next thing now is to look for the formula for the distance between 2 points, which is formula number 7 on maths level 4 formula sheet. So that's the formula for the distance between 2 points. So we use our 2 points as our x1, y1, x2, y2. So if I choose my x2 to be 3, means to be negative 5, means I'll get negative 5 minus negative 2, I square it. Then if my y2 is 3, means I get 3 and my y1 will be negative 1, I square that. So this gives me my distance for AM. So this is a 2 minus a 3, 2 minus a 5 is negative 3 squared is a 9, 3 plus 1 is a 4, 4 squared is 16. That means I have 5 as my distance between A to M, which is the radius of the larger circle. So I can just call it RAM, which is the radius of the larger circle. So now that we know the radius of the larger circle and we know the coordinate of the center, we can therefore write down the equation of the circle as x minus 2 squared, which is the x coordinate of the center of the circle, plus y minus negative 1 squared is equal to 5 squared. So this reduces to x plus 2 squared plus y plus 1 squared is equal to 25. So if we were to leave the equation in this format, then we would say we have arrived. But unfortunately, we need the general format of the equation of the circle. That therefore means we must expand this. So we have to expand this to get 3 terms, we expand this to get 3 terms. So I will show the expansion for each in the rough page before I come back. If I need x plus 2, all that square. If I were to expand like a high school student, I will take my x times x, which is x squared. X times 2 is 4x. Then 2 times, x times 2 is 2x. 2 times x is another 2x. Then 2 times 2 is 4, then the 2 middle terms are like terms which will add up to 4x plus 4. So that is what my first term gives me if I'm using the long method of expansion. That is what I get. But there is also a shorter method where I simply take x, I square it, I get x squared. You take 2, you square it, you get 4. Then in the middle you take 2 times x, it gives you 4. So that is a short method that I always encourage my students to learn it. So try that short method here. You take y, you square it, you get y squared. You take 1, you square it, it gives you 1. Then in the middle I will take 2 times 1 times 2 times y. That gives me 2y. So I've always emphasized that you only use this method when you are very sure that your exponent is 2 and you have 2 items in there. So this is equal to 25. So if we now pull everything on one side so as to get the format required in the equation, then we'll be having our x squared plus y squared plus 4x plus 2y, then 1 plus 4 plus 1 is 5. If 25 crosses becomes negative, so you get 5 minus 25, which is negative 20, equal to 0. So guys, that is our solution for the A part of the problem. We've succeeded to calculate the equation of the larger circle, and we've put our answer in the format that was required in the question. So let's now go to the B part, which says, given that the equation of the smaller circle is now something of this format. So we've got this equation of the smaller circle as x squared plus y squared plus 4x plus 2y minus 4 equal to 0. We have to determine the length of AB. So the length of AB, as you see in the diagram, is from the circumference of the larger circle to that of the smaller circle. Generally, if I know AM, which I believe we know it already, we've calculated AM as 5, then I know BM, then I can take AM minus BM, I'll get AB. So to know BM, we need to get that from the equation of the smaller circle. And here, we're dealing with the smaller circle, but the format has to be transformed from the general format to something of this nature. So to do that, in this particular case, unfortunately, we'll have to apply the technique of completing the square. Because to move from something like this to that one, we complete the square. To move from here to this one, we expand. So the unfortunate thing here is that we have two quadratics involved here. So we must pull them together first, and then we complete the square of each quadratic. So my very first step will be to pull the two quadratics together. There is a quadratic in terms of x, which I have it like this. So this is like my first quadratic. Then my second quadratic in terms of y, we have y squared plus 2y together. So I've taken x squared plus 4x, y squared plus 2y. I pull them together. Then this constant, I will send it to the right hand side, since it's neither belonging to the first quadratic or the other one. Then I complete the square like we always do in math level 3 or maybe in the high school. So when I'm completing the square of the first quadratic, I have to capture my first two terms exactly the way I see them. Then I take half the coefficient of x. The coefficient of x is that number in front of x. So that number is a 4. A half of 4 is a 2. So if I write it that way, I'll be having a 2. Then I will square it. I add it to the left side. Then I also go to the right side that already has 4. I also add 2 squares. So let me take a bit of space. I also add 2 squares. So you see, I took half the number in front of x. Half of 4 is a 2. You square it, you put on the left, and you also put on the right. So I've completed the square of the first quadratic. I will do the same thing for the second quadratic. So I get my y squared plus 2y. Then the coefficient of y is 2. Half of 2 is 1. That means I'll take 1, I square it, I put it on the left, and I also put it on the right. So this is how we're completing the square in level 3. The only issue here is that we're only doing it with one function. But now we've got two functions, one in terms of x, one in terms of y. So we must just concentrate and complete the square of that one and the other one, and we'll add our constants to both sides. So in that way, we can now see two complete squares. The first one is in terms of x, the second one will be in terms of y. So when you want to capture the complete square, for the first complete square, I only look at the two items carrying the squares. I bring them down, so I'm bringing down x, and I'm also bringing down 2, then I put a square on that. So this item represents all the 3, just like we've seen before in expansion, that if you take x, you square it, it gives you this. You take 2, you square it, you get that. Then the person in the middle is 2 times 2 times x. So that is how it is. Then we do the same thing for the next quadratic. So this is a complete square. To see that complete square, I look at the two items with the square. There is a y, and the other one is a 1. Then if you square that, it takes care of all those three. The same thing as I can say if I take y squared, it takes me there, 1 square goes there, then 2 times 1 times y takes me to the middle. So that is how we complete the square, guys. Then if we go to the right hand side, we can just use our calculator to calculate that. So 2 squared is 4, 4 plus 4 is 8, plus 1 is 9. So in that way, we succeed to transform the smaller circle from the general format to this one. So, and we know that this format is something like that. So the number on the right is supposed to be the radius of the smaller circle. So we've got our radius, if we put it in terms of square, as a 3. So in this format, we therefore see that the radius of the smaller circle, which is, we can call it RBM, is equal to a 3. And therefore, our distance AB, looking back at our diagram, if you check your distance AB, as we explained, is supposed to be AM minus BM. That's how we get our distance AB. So it is AM, the radius of the bigger circle, which we got, minus BM, the radius of the smaller circle, and that is 5 minus 3, which gives us a 2. So guys, for the second part of this problem, I guess we are also done. We've succeeded to calculate the distance AB. So the last part requires us to get the equation of the tangent at A. So because of space, I will have to bring down this one. We need the equation of the tangent at A. So a tangent is a straight line that touches a curve. So that tangent was not shown on our diagram, but if I were to show it, I will be drawing a straight line that touches the curve at A. So that immediately reminds me that the equation of a tangent must be in the format of the equation of a straight line. I'll call it MT, referring to M tangent. So that will be my equation if I'm using formula number 3 on the formula sheet for maths level 4 students. So my x1 and y1 will obviously be the coordinate of A. So what I'm left with is to get the gradient of the tangent. And since you don't know 2 points on the tangent, the only way you can get that gradient is to exploit the relationship between a tangent and a radius. This is a relationship that all level 4 students must know it up by heart. That the radius is always perpendicular to the tangent. That is one of the theorems of the circle. So if it is like that, it means therefore that the gradient of the radius multiplied by the gradient of the tangent must give us a negative 1. So if we can succeed to get the gradient of the radius, then we accept. So to get the gradient of the radius, we either calculate the gradient of AB or BM or AM. So any of them will be fine. So I'm going for the gradient of the radius, which we'll be using the formula y2 minus y1 on x2 minus x1, which is formula number 2 on maths level 4 formula sheet. So my y2 on my graph, I'll take it to be 3. My y1 is a negative 1. Which is the common distance, the common center, sorry. My x2 will be negative 5, my x1 will be negative 2. So if I simplify this, numerator is a 4, denominator is a negative 3, because this is 2 minus 5, it's a negative 3. So that's the gradient of the radius. So therefore, if I take it back to this relationship, I'll be saying negative 4 over 3 times the gradient of the tangent is negative 1, and after dividing both sides by negative 4 over 3, the gradient of the tangent will be the 3 over 4. So with this, I've managed to get the item that will go there. I know my x1 to be negative 5, since we're calculating the gradient of the tangent is at A, then my y1 is 3. So therefore, if I get back to that equation of getting y minus 3 y alternate of A is equal to the gradient, which is 3 over 4 into x minus negative 5. That is the x alternate of A. So if I now open the bracket, I get y minus 3 is equal to 3 over 4x plus, this becomes positive, 3 times 5 is 15 over 4. And this 3 will cross over to make 15 over 4. And if I use my calculator to do the addition, I guess 3 will cross over as positive 3, and positive 3 is like 12 over 4. 12 plus 15 is 27. So that will give me 27 over 4 if we use our calculator. So guys, that is how to handle that question. We've done the first part, second and the third. I guess that is okay. Thank you very much.